So let's read. So again, reading is one of the key things that people miss. And when I say people, I'm talking about me. Okay, so I tend to just skip over the wording and then just solve. And then I end up solving for the wrong thing, or I just solve it wrong because I didn't really read through it. So let's read through it. A store owner want, that's Mr. Sells typing right there. A store owner want to develop a new snack mix by mixing chocolate and trail mix. How many pounds of chocolate costing $9.10 per pound should be mixed with 20 pounds of trail mix costing $3.80 per pound to create a mixture worth $5.68 per pound, round to the nearest pound? Okay, so I've got two things going into this trail mix, okay, and I want to identify those right off the bat. Is looks like we're putting in some chocolate, right? Chocolate, and then we're going to put in some trail mix to create some kind of mixture, like a chocolate trail mix. I don't know. But in any case, we got some chocolate going on, right? So let's put that down here. And then we got some, I guess I kind of covered that up. Hopefully that's okay. Trail mix. Now, we got two equations to write on the chocolate and the trail mix, okay? And the first thing that I noticed here is that we have a price for the chocolate, a price for the trail mix, and then a price for the mix, okay? So let's create an equation just based off of the price. Yeah, I guess you could say cost if you wanted to, but it doesn't matter. So chocolate, excuse me. I'm gonna use, I want to use X so bad right here, but most students say that they'd prefer I use C. I'm talking about past classes. They want me to use the variable C for chocolate, okay? All right, no problem. Now, how do we find the price of the chocolate? Just the chocolate part of the mix. Well, we know it's $9.10, at least that's what the problem said. That's for every pound of chocolate that's used. So I would multiply that by C, which I'll define as pounds of chocolate, some kind of chocolate. So C is pounds of chocolate, okay? So $9.10 times the number of pounds of chocolate, that would tell me the price of just the chocolate part of it. But then we have the trail mix, which, again, I want to use Y, but we'll use T. That will be pounds of trail mix. All right, so if I wanted the price for the trail mix, it says that we got $3.80 for every pound of trail mix, but it also says we're using up, I apologize, I do not need T on here for my trail mix. Fair enough.
What are you going to use?
So yeah, we don't need the T for the trail mix because we know how many pounds of trail mix. This is why it's important to read and reread the problem right here, which I probably should have done the second time. 20 pounds of trail mix, we already know is 20 pounds of trail mix. So the other variable, right? Well, what is the other variable for? We're looking at the final mixture. I'm going to put final mix. Now the final mix, the pounds of final mix, I don't know, I guess I probably shouldn't use F, but that's okay. F is the pounds of the final mix, okay? All right, now do we know how many pounds that is? No, that's why I have to use a variable for it. But it says here, 568 for every pound. So the final trail mix should be $5.68 for every pound. We just don't know how many pounds it is. So, but I did say that we'll use F. I don't want to use lowercase f, then it looks like a function. So maybe F isn't a very good letter to use, but it doesn't matter, right? Because we're creating this ourselves. So if you took the cost or the price for the chocolate and then added that to the price of the trail mix, you should get the overall price of the final mix. Right here, there's, boom, that's one equation right there. And I can tell by everyone's faces how much fun that was. Okay, now Now we gotta create an equation. What was the other quantity that was given to us? It's pounds. We got pounds of mix, pounds of trail mix, and then pounds of chocolate, right? So we got the next equation is based off of the pounds. Okay, so how many pounds of chocolate were there? C. That's all we had. And then the trail mix, yeah, 20 pounds. And then we had pounds of the final mix, which I would consider that the total, but we don't know how many pounds that is. It's some kind of F number right there. So if you take the C, pounds of chocolate plus the 20 pounds of trail mix, you would have the final mix pounds right there. So I took quite a bit to set that up, because usually this is the hardest part that most students struggle with. If they can get this system down, it's like, oh, I can solve it now, but you just got to get to this point, right? So yeah, this are we going to use substitution? Now, if I were to look at this, I'd see, right, this is F equals something. So the answer is you could. Okay, well, what other method could you use? Well, the only one we have used in this class is elimination, which you could use as well. Doesn't matter. Since this is set up as F equals something, yeah, I probably would go into substitution right here. So here's what we mean by that. Let's take that first equation based on the prices. So there's that first equation based on price. I just copied it down exactly, but now I'm going to substitute the F letter or variable with what F represents, which is the cost plus the 20. And this now is an equation with one variable. Hey, that's not too bad, right? Like we can solve that. We do have some distribution here, so I should get my calculator out. Let's go back because I skipped that part, right? It's not just 20, yeah, so.
You don't need a raise.
Well,
No, you do.
yeah, well, there's one at the store I can let you get, It's available anytime, by the way. So I forgot to do this multiplication. Let's do it now before I forget, because I already forgot once.
7,600?
By the way, you guys told me it's 76. I believe you. It's just, as a math nerd, it always makes me nervous. Oh, I apologize. This, by the way, was 20, but I'm still making mistakes here. But just the math nerd in me is like, is it really 76? I trust you guys. Okay, so that's 76. Not, I had the 20 over there, right? Yeah. What the heck did I do? So 76 right there. Okay, now we're ready to do some multiplication. And before I ask, because then it's just the math nerd in me, I do apologize. I've now done, so that no one can tell me, 5.6. I know 5.68 times C is just 5.68C.
Do you do that in your head?
Well, that part, yeah. It was, yeah, right. I should get like a treat or something. But I did 5.68 times 20 as well, so 113.6. And then the rest of that, or the left side of that equation stays the same.
Can you multiply that by 100?
Yes, you can multiply both sides by 100 to get rid of the decimals. I'm keeping the decimals because I'm doing all the calculations on this sucker right here, the calculator. And it will do it for me, but also happily. So now I'm going to use principle of equality. I'm going to do two principles of equality in one. I'm going to place my C's on the left side and the numbers on the right. If you've never seen this before, let me explain briefly though. So I want all my C terms on the left and then all my constants, just the regular numbers, on the right side, which means that plus 76 there in purple, it's on the incorrect side. I'm going to have to zero that out. But it is a principle of equality, so if I do it to one side, I need to do it to the other side. Now, I'm not worried about the calculation because we'll get there. But then we also have 5.68C in orange on the right. It has to be zeroed out as well because it's on the number side of things. So I'm going to have to subtract 5.68C from the right side and the left side just to maintain my principles of equality. So that'll tell me how many C's I get on the left. Let's see what that is. So 9.1 minus 5.68. Enter. And I get 3.42 C's on the left. So the 76 minus 76, yeah, that zeroes out. 5.68C minus 5.68C zeroes out just as we planned, okay? So that's principles of equality. We could have literally subtracted or added to anything as many as we wanted to, but we're doing that with purpose to force zeros to happen. Then I can take the 113.6 minus 76 as well, which now shows 37.6. Now we only want 1C, right? So we're going to divide now both sides by 3.42. So what this does is it makes that 1C, which is really what we want. I'm just going to show it a C, by the way. And then 37.6 divided by 3.42. Enter, and I get 10.9. Here's what I get, 10.994. I'm going to stop there. Now, and that was pounds of chocolate, right? So that's a pound of chocolate. Yeah, they do want us to round to the nearest pound. And when it comes to chocolate, I would just prefer to just round up, but it's going to be the same thing. That's going to be 11 pounds right there. Okay, now that's just pounds of chocolate, right? Oh, crap. I guess I should label it pounds of chocolate, even though I have it color-coded.
Minus 1 point.
No, I remembered, so I'm good. So, but we do have the pounds of trail mix as well. We want the final mix, because it did say, where it is, how many pounds of chocolate costing this, pound of the mixture. Oh, I guess it did just want the chocolate, but we could find the final mix, right? Because we can go to that second equation that's based on pounds. We now have chocolate at 11 pounds, and then we could have just said, well, 11 plus 20, boom. That would have been 31 pounds of total mix. I guess they didn't really ask for that though.